Welcome back to Business Analytics for Decision Making. In this lecture, we're going to introduce queuing, which is the start of our first block. Our lesson objectives: we're going to discuss what causes a queue, why we model queues, what cost firms balance when designing queues, what info we need to model a queue, and finally the different types of queues that are out there. So what causes a queue? And a queue is waiting in line, and it's caused by variation. So we can have variation in arrival. So when two people arrive right behind each other, well, suddenly there will be a line, even if the service rate is fairly quickly. Sometimes two people arrive almost simultaneously. The other factor that we have is service variation. So some customers may be more difficult to process than others, whereas others will go very quickly. To model a queue, there's two basic approaches. The first approach is analytic models, and these use equations, and it's what we're going to do here. This works really well for simple cases, like almost every fast food restaurant out there, and to be honest, does very well in even more complex cases. The second approach is simulation, and this is necessary when you want to be very accurate or look very detailed at more complex systems. For example, low observable aircraft maintenance systems, the F-22 and F-35. When the Air Force analyzed those processes, it needed to do a simulation because it wanted to look at very small portions of that system in relation to the entire complex system by which maintenance is undergone. So why do businesses model queues? And the answer is to balance two costs. The first cost is service cost, and this is the cost of providing service. So do I have one person helping my customers, or do I have two people helping my customer? And so service costs are linear because I know how much I'm going to have to pay for each additional server I have. The second cost is waiting cost, and this is essentially the cost of not providing service. So if I have a whole bunch of customers that show up, how long do they have to wait before they're served? And so if they're employees, right, there's obviously the opportunity cost of them potentially doing other work. If you're a storefront, you have the risk of them bulking, which is they leave without making a purchase, so that's foregone earnings. The other option is they can buy and never return. And in this case, they get so fed up with waiting in line, they go through and buy this one time, but you lose all subsequent sales. So a firm's goal is to minimize cost. Visually, what does minimizing queue cost look like? And so I can create this by a simple graph. Along the bottom is our decision, and this is our service level, the number of servers we want to hire. Along the vertical axis, the y-axis, we can put the cost of operating the service facility. The first thing we'll plot is simple as service cost. And this is a linear line that increases with each additional server I decide to provide. Our second cost is the wait cost, and this is nonlinear. If I only have one server, I can have a really, really long line, whereas if I add a second server, this can probably handle almost all of our customers. If I then add a third server, you could imagine that it would create a really small reduction if two servers already handled most of my customers. Right, so they'd be additionally idle. And so the wait cost has this nonlinear curve. What a company is concerned with, though, is the total cost. And our total expected cost is the sum of service cost plus wait cost. And what the business wants to do is locate right at the minimum of that total expected cost, which is where service cost and wait cost intersect. And that's our optimal service level. For those of us that prefer an example, we can go back to our coffee shop. And so in creating this new coffee shop, we need to decide on the number of baristas to hire, 1, 2, 3, or 4. And so if I have one and I'm paying them $60, I have to pay $60. If I hire 2 baristas, it'd be $120, 3, $180, so on and so forth. Now, my customers are going to show up based on the number of baristas I have. And I can then measure what the average time a customer waits is. So maybe I have 4 baristas on staff, and I can try different experiments with having 1 working, 2 working, 3 working, and 4 working, and then timing the average wait a customer has to get their coffee. If I know the average time a customer waits, I can compute their waiting cost, which is the average number of customers times their average wait, times my estimate of how much it costs to wait. So if I say there's an average of 5 customers in line, and it costs me about $10 a minute to make them wait, then I've got my waiting cost. My total expected cost then is just the sum of my wait cost and my service cost. So in the case of 2 baristas, my waiting cost is $200. My service cost is $120, so my total expected cost is $320. As a business, I'm going to minimize my total expected cost, so I'm going to end up hiring 2 baristas. What do we need to model a queue? We can see the benefits of doing it. The first thing we need is the arrival rate. So how fast are my customers going to show up? The second thing we need is our service rate, which is how fast can my server handle the customers? Our third thing is the number of servers. So do I have 1, 2, 3, or 4? Because all of them will provide service to my arrivals. Optionally, we can also have a maximum queue length. So in some systems, you can imagine a capacity. So if I can only fit so many customers in my store, say 4, I'm going to lose all customers greater than 4. Our final thing that we can do is population size. So you can imagine a small population, and if 4 people are already in line, it's going to affect my future arrival rate. The things that we have to model our queue are the arrival, service rate, and number of servers. And optional elements we can incorporate into our analytic model are the maximum queue length and population size. So what are the types of queues that are out there? The first is a single server, single phase queue. And this is like McDonald's or an ATM. So you've got 1 server, and they're providing service to a single line. A customer comes up, they get help, the line moves forward, and they leave. The next type of queue is a single server multi-phase, and I like to think of this as Chipotle. So again, you've got a single line, and then they step up to service, and then without proceeding back into another line, they continue with service. So they move forward through the different stations. So they get their tortilla and their meat, they then get their salsa, they move forward and check out, all without waiting in line again, and then they can exit to eat their burrito. The next type of queue is a multiple server, single phase, and this is Chick-fil-A. So in this case, you've got lots of servers available, and they're all providing service to a single line. So you're going to move forward to the first available server. And when all the servers are taken, right, once someone leaves, the next person in line is going to step right up. The final type of queue is a multiple server, multi-phase. And this is a lot like a laundromat. So when I show up to a laundromat, it almost always seems to be busy. Everyone's at all the washing machines, everyone's at all the dryers. In which case, I'm almost always going to end up in a line. And eventually someone's going to finish with the washing machine, and of course no one's finished with the dryer, so now there's also a line for the drying machines. So I can step forward and begin the first step in this process, which is washing my clothes in the washing machine. While I'm washing my clothes, another person may finish, and now there's an even longer line for the dryers, but someone else could then begin using a washing machine as well. Eventually someone's going to finish with the dryer, and then someone can step forward that was in the dryer line to finish the process of drying their clothes. And so this is a multiple server, multi-phase system, where you can be waiting in a line twice. So let's recap the types of queues. To begin with, there's the single server, single phase. This is our McDonald's or ATM. So customers arrive, they enter a queue, they're provided service at a single service facility, and then they get to depart. For the single server multi-phase, like Chipotle, customers arrive, they enter the queue, And once they get to service facility 1 and they're processed, they proceed immediately to service facility 2, service facility 3, so on and so forth, without waiting in a queue again. And then they depart after they've received all the service required. In a multiple server single phase system like Chick-fil-A, customers arrive and enter the queue, and once they're at the front of the queue, they proceed to any of multiple service facilities, all of which are equivalent. When they're done at the service facility, they depart. In a multiple server, multiple phase system like a laundromat, arrivals come and they enter a queue for service facility 1, which there can be many of. Once they're at the front of the first queue, they enter to whichever of the first service facilities is available. When they're done, they enter a second queue for the next stage of the process. Once they're at the front of this, they proceed to the first available service facility 2, and once they're done, they can depart. So what were our lesson objectives? The first was to answer what causes a queue, and that was variation. After that, we discussed why we model queues, which is to minimize total cost for a business. Then we discussed what cost firms balance when designing queues, and that was the service cost, right, how many servers I have, versus the wait cost, how long I make my customers wait. Then we looked at what info we needed to model a queue, and that was the arrivals, the service rate, and the number of servers. But we could also include in our model a maximum queue length or a population size. Finally, we discussed some types of queues in terms of their stages and the number of servers. So that concludes this lesson. I look forward to seeing you again next time.